Good morning class. Welcome back to grade 5 mathematics. How are you all doing today? Today let's learn how we can compare like and unlike fractions. Let's see the case of like fractions first. So what are like fractions? The fractions with the same denominator are called like fractions. Look at this example given here. Here in the first image or the first picture, the circle is divided into 5 equal parts 1, 2, 3, 4, 5 and we have one part colored. So what is the fraction of the colored part in this case? It is 1 by 5. 1 is the numerator, which is the number of parts we are considering, by the whole or the total number of equal parts, which is 5. So in this case, the second picture, we have 2 parts colored and here the fraction of the colored part is 2 by 5, and in the third case we have 3 equal colored parts and hence the fraction for the colored part is 3 by 5. See, in all these cases the total number of parts, it is equal to 5. It is all the same. Now only the parts we are considering is different. So when we have the same total number of parts, that is we have the same denominator, we call them like fractions. Now how do we compare them? So since we have the same denominator or the same total number of parts, it's enough that we compare the numerator. So to compare like fractions, we just compare the numerators. Now let's see one example. See this question. Shyam, Ananya and Vicky are reading books with 100 pages each. Shyam has read 3 by 10th of the book. Ananya has read 7 by 10th of the book and Vicky has read 9 by 10th of the book in a day. Who has read the maximum number of pages? So, all these 3 children, they are reading a book and the book has 100 pages each. And Shyam has read how much? 3 by 10th of the book or 3 by 10th of the total number of pages of the book. Ananya has read 7 by 10th of the total pages, means 7 by 10th of 100, and Vicky has read 9 by 10th of 100 pages. Now we are asked to find out who has read the maximum number of pages. We can do this question in 2 methods. Let's see the first method. Let's find out how many pages each of them read. How do we find that? So Shyam has read how much? 3 by 10th of 100, which is equal to 3 by 10 into 100, that is equal to 30 pages. And what about Ananya? Ananya has read 7 by 10th of 100 pages, which is 7 by 10 into 100, that is equal to 70 pages. Now Vicky has read 9 by 10th of 100, which is equal to 90 pages. So who has read more number of pages? Yes, Vicky has read more number of pages or the maximum number of pages. Here we actually found out how many pages they read. So this is one method. So we'll see the second method. Since we have the same denominator, like we said earlier, to compare like fractions, it's enough that we compare the numerators, and when the numerator is the greatest, the fraction will also be the greatest. So here we have the fractions 3 by 10, 7 by 10 and 9 by 10. These are all like fractions. It's enough that we compare the numerators. So comparing the numerators, which is the greater number here, it is 9, right? So we can write this 9 is greater than the next, it is 7 greater than 3. So which is the greater fraction? 9 by 10 is the greater fraction. So Vicky was the one who read 9 by 10 pages of the book. So from this we can directly say Vicky is the one who read the more number of pages. So this is another method. I hope you are clear with this. That was about like fractions. Now how do we compare unlike fractions? What are unlike fractions? The fractions with different denominators or the fractions with different total number of parts are called unlike fractions. How do we compare unlike fractions? There are 2 cases when we compare unlike fractions. Let's see the first case, the fractions with the same numerator. For example, 1 by 12. Now 1 by 15. See, are these like fractions? No, they are not like fractions, but they have the same numerator. So in such cases, the fraction with the larger denominator will be the smaller fraction. Why so? Here we are considering one part of total 12 parts. In this case, we are considering one part of total 15 parts. So which part will be smaller? One part out of 15 parts, right? So that's why we said the fraction with the larger denominator will be having the smaller value. Look at this example here. Arrange 5 by 12, 5 by 23, 5 by 17, 5 by 11 in descending order. See, all these fractions are having the same numerator. They all have 5 as the numerator and the denominators are different. Now, how do we compare them? Since the numerators are the same, let's see the denominators. We have 12, 23, 17 and 11. Which is the greater numerator here? 23, right? So, in this case, we are considering 5 out of total 23 equal parts. So, this will be the fraction which has the smallest value. So, among these 4 fractions, this will be the smaller fraction. Which will be the next smaller one? The next smaller one will be 5 by 17 and the next one will be 5 by 12 and the last one will be 5 by 11. So, among these 4 fractions, the fraction having the greater value will be 5 by 11, or that is the biggest fraction. We are asked to write or arrange these fractions in descending order, that is from the bigger to the smaller, right? So, here we have 5 by 23 as the smallest. The fractions arranged in descending order will be 5 by 11 is greater than 5 by 12, greater than 5 by 17, greater than 5 by 23. This is the biggest fraction and this is the smallest one. Clear? Now, let's see the second case, fractions with different numerators. So, in the previous case, we saw fractions with the same numerators. Now, what if the fractions are different numerators? So, in this case, we have to first convert the unlike fractions into like fractions by making the denominator same for all the fractions. How we can do that? We'll see with an example. Arrange 2 by 3, 4 by 5, 5 by 6 in ascending order. So, these are all unlike fractions and they have different numerators as well. Now, we have to change all the denominators to the same number so we can compare them like in the case of like fractions. The easiest way to do that is to find the LCM of all the denominators first. Then, you have to multiply both the denominator and the numerator by a suitable number so that the denominator will become the LCM obtained. Let's see how we can do that. So, which are the denominators here? 3, 5 and 6. Let's find out the LCM of these denominators. So, here we have the numbers factorized. How we take the LCM? We have to take the product of the common and non-common prime factors. So, which are the common prime factors here? We have 3 as a common prime factor. We take the product 3 into and the non-common prime factors are 5 and 2. So, what is 3 into 5 into 2? It is equal to 30. So, the LCM of 3, 5 and 6 is equal to 30. Now, what is the next step? Now, we have to multiply both the numerator and the denominator of the given fractions with a suitable number so that the denominator of all these fractions will become the LCM we got. How we can do that? Let's see. So, the first fraction here is 2 by 3. We have to change this LCM to, the denominator to 30, which is the LCM. For that, we have to multiply both the numerator and denominator with the same number. So, how we know which number we have to use to multiply? So, here we have the LCM 30. Let's divide this denominator and the LCM. So, How many 3's will make 30? How we can find that? We have the LCM here, 30. Then divide this numerator with that. 30 divided by 3, which is equal to 10. So, if we multiply both this numerator and the denominator with 10, we can change this denominator to 30, right? So, let's take 10 here. 2 into 10 is equal to 20 and 3 into 10, 30. See, the denominator here is changed to the LCM obtained. Now, the second case, 4 by 5. How we can change this 5 to 30? What is 30? The LCM divided by this 5, which is equal to 6. So, let's take this 6 to multiply both 4 and 5. So, 4 into 6 by 5 into 6. We get 24 by 30. Now, the third case. What is the fraction? In the third case, the fraction is 5 by 6. And how we can change it? What is 30 divided by 6? 30 divided by 6 is equal to 5. So, let's multiply this 5 with both the numerator and the denominator. So, 5 5's are 25 and 6 5's are 30. Now, see, in all the fractions we have the same denominator. Now, these fractions are changed to like fractions. They all have the same denominator. So, in this case, we can compare these fractions by just comparing the numerators 20, 24 and 25, and we can easily find which is the smallest and the largest fraction. So, among these fractions, which is the smallest one? 20 by 30, right? 20 is the smallest numerator here. So, 20 by 30 less than 24 by 30 less than 25 by 30. So, we have the corresponding or the equivalent fractions arranged in ascending order. So, the given fractions arranged in ascending order will be 2 by 3 less than 4 by 5 less than 5 by 6. I hope this is clear to you. Now, you can go through the topics comparing like fractions and comparing unlike fractions in page number 60 of your textbook. Once you have done that, please move on to exercise 4.2. Please complete all the questions. That's all for today. We'll meet in the next class with a new topic. Until then, bye.